Hi, I'm Odeme Ebere from lowlessons.com. In this additional mathematics, I'll be taking you on matrices. Matrices is an arrangement of elements, components, items, etc. in rows and columns. In matrices, we use capital letters to denote the matrix itself and small letters to denote the component of the matrix. Example, matrix A equal to A, B, C, D, E, F. Here you can see that we use a capital letter to denote the matrix itself and the small letters to denote the component of the matrix. In matrix, we have what we mean by dimension of a matrix. The dimension of a matrix is simply the number of rows and columns present in the matrix. Example, like the matrix above here, the dimension of this matrix is simply the number of rows times the number of columns. Here, the horizontal elements constitute what we call rows, whereas the vertical component constitute what we call the columns. Therefore, elements which constitute the first horizontal here will be said to be elements of the matrix in row 1. And that in the second horizontal line will be said to be elements of matrices of row 2. Whereas here, we'll call this one column 1, column 2, column 3. Therefore, we can say that the dimension of this matrix is 2 by 3. That means 2 rows by 3 columns. Therefore, dimension of A is equal to 2 by 3. The dimension of this matrix is simply 3 by 4. That is, you can see here we have 3 rows and 4 columns. Therefore, the dimension of this matrix is 3 by 4. B is of dimension 3 by 4. Types of matrix. We have different types of matrix depending on the way the matrix is formed. One, we have a null matrix. Null matrix. A null matrix is one whose its elements are 0. Example, matrix n equals to 0, 0, 0, 0, 0, 0, 0, 0, 0. That is a null matrix. We also have a square matrix. A square matrix is one whose the number of rows equal to the number of columns. For example, S equals to minus 2, 1, 3, 0. This is a square matrix because the number of rows equal to the number of columns. Here you can see that this is a 2 by 2 matrix. We also have a diagonal matrix. Diagonal matrix are matrices that are square matrix, and elements only constitute in the leading diagonals, whereas others are zeros. Example, D equals 1 0 0 0 2 0 0 0 minus 1. You can see that the component of this matrix is zeros, except those on the leading diagonal. We also have an identity matrix. An identity matrix are diagonal matrix for which the elements in the leading diagonal are 1. Example, I equals 1 0 0 0 0 1 0 0 0 0 0 0 0 1 0 0 0 0 1. Here you find it that this is a special case of an identity or a diagonal matrix for which the leading diagonal contains the element 1 and 0 elsewhere. Any two matrices or more will be said to be conformable for addition if they are of the same dimension. I repeat, any two matrices or more will be said to be conformable for multiplication or for addition if they are of the same dimension. Example, if matrix A is equal to 1, 2, minus 3, minus 1, 2, 1, 0, 0, minus 5. And matrix B equals to minus 1, 3, 3, 1, 1, 1. We cannot add the matrices above because the number of rows is not the same as the number of rows here in this other matrix. So therefore, they are not conformable for multiplication for addition. We will only add these two matrices if and only if they are of the same dimension. For example, if matrix P is equal to minus 1, 3, 2, 2, 2, 4, and matrix Q is equal to (3 minus 1 minus 2, 1, 1 minus 3), we can add the two matrices because they are of the same dimension. If you look here, you find that we can add these two matrices because they are of the same dimension. Therefore, addition is done correspondingly. Addition or subtraction is done correspondingly. Like if I want to add these two matrices, say that P plus Q is equal to matrix P, which is minus 1, which is equal to minus 1, 3, 2, 2, 2, 4, plus matrix 3, minus 1, and minus 2, 1, 1, minus 3. So the addition there is done correspondingly. Like we can put all these in this form, minus 1 plus minus 1. That is this minus 1 plus this 3 minus 1 from this other matrix, plus 3 from this other matrix. Therefore, this 3 here plus minus 1. 3 from here plus minus 1 from here. And 2 from this other matrix. Similarly, say 2 plus 1, 2 plus 1, and 4 plus minus 3. So therefore, working out the arithmetic, we have minus 1 plus 3 give us 2. 3 plus minus 1 will give us 3 minus 1, which is 2. And 2 plus minus 2, which is 2 minus 2, which gives us 0. 2 plus 1 gives us 3, and 2 plus 1 gives us 3, whereas 4 minus 3 will give us minus 1. So, addition is done if and only if the dimension of the matrix or the matrices are the same. And when it is done, it will still give you the matrix of the same order. In a similar way, subtraction can be done. Like if you want to subtract two matrices, maybe matrix P from Q, we still consider these matrices. Matrix P, matrix Q subtracted from matrix P. So therefore, see that P minus Q is equals to matrix P minus 1, 3, 2, 2, 2, 4, minus matrix Q, which is 3 minus 1 minus 2, 1, 1 minus 3. So we put it together to have minus 1 minus 3, 3 minus minus 1, 2 minus minus 2, 2 minus 1, 2 minus 1, and 4 minus minus 3. And so we now have minus 1 minus 3 gives us minus 4. 3 minus minus 1 gives us 4. 2 minus minus 2 gives us 4. 2 minus 1 here gives us 1. 2 minus 1 here gives us 1. And 4 minus minus 3 gives us 7. So that is the subtraction of the two matrices. Thank you.